Welcome to the Weather Review, the podcast that is not your typical forecast. Weekly, we look back at weather events that may have made the news in an attempt to explain what happened and why. I'm your host, Gavin White, and I welcome you to this week's Weather Review. Montpelier, the capital city of Vermont, was underwater last week. The state saw record flooding as a slow-moving system brought monumental amounts of rain into the region, with some county estimations as high as 9 inches throughout the course of the two-day event. The intense rainfall and severe flash flooding led to 1 death, injuries, and vast amounts of damage. A low pressure developed along a cold front met profound saturation levels and an atmospheric roadblock leading to the event. Now, these profound saturation levels associated with this rainfall, the system initially started as a line of storms that developed along a south to north oriented cold front, so a vertically oriented cold front. It was coming into the region from the west, moving from the west to east, vertical cold front moving into the area. Storms were developing along it. The region up in the New England area had nearly 2 inches of precipitable water. Now, precipitable water is an indication of the amount of moisture in the atmosphere at a given time. Pretty much it's how much liquid water would be on the surface after precipitating all the water vapor vertically above a given region. So in this particular region, in the Vermont, New England area, there was nearly 2 inches, or what would have been 2 inches of rainfall on the surface in the form of water vapor from the surface up to about 30,000 feet, give or take. Now, normal for this time of year in this region is about 1 inch of precipitable water. So there was nearly double the amount of precipitable water in the atmosphere. So we had a very saturated atmosphere, and this is largely, not entirely, but largely attributed to a warmer Atlantic Ocean. It contributed with the fact that warmer temperatures are going to lead to more evaporation. More evaporation is going to lead to more water vapor in the air, which is going to contribute to that precipitable water and fuel for the system. So the atmosphere is very saturated. There's a lot of moisture in the air over Vermont leading up to this. In addition to that, we had a very saturated ground. Since the final week of June up until the event, many places across Vermont received anywhere from 4 to 8 inches of rain. That's 150 to 300% higher than typical for this time of year in that region. As a result, the grounds across the state and the region were very, very saturated and really couldn't hold any more water. The ground's fully saturated, has as much water in it as it possibly can, and the atmosphere is very saturated for this region for this time of year. So as a result of a very saturated ground, there's not really many options for any additional rainfall to go. As a result, it's going to convert into runoff and go down to the rivers. Now, what's interesting about Vermont and its topography, its terrain, it's a very mountainous state. So there's a lot of valleys in between steep terrains, steep slopes. So when you have a very saturated ground, when you get any more rain, that runoff is going to run to rivers. Being this region and the topography it has is very mountainous, that runoff is going to collect a lot faster than it would over more flatter watersheds. In this case, when you have record rainfall, that water is going to collect very quickly in the rivers that are flowing in these valleys between the mountains. And it's going to rise a lot faster than it would over a much flatter, more spread out watershed. So there is a saturated atmosphere, there is a saturated ground, and now you have rivers that are flooding because all the excess water is running straight to the rivers, causing those to flood and overfill, adding to it further widespread flooding. We can insert Montpelier, Vermont as an example right here. I'll include links to images of that city in the show notes for this episode, just so you can see the amount of flooding that resulted from this system. So what actually led to this event in the first place? We know we have all these atmospheric and topographical conditions out of here. There's a lot of moisture, a lot of precipitable water in the atmosphere. And we know they had a lot of rain in the little under 2 weeks leading up to this event. There's a lot of rain in the area, led to a very saturated ground. A lot of water in the air, a lot of water in the ground. What led to the additional rainfall? Why was it over so much rain in such a short period? Yes, there's a lot of water in the air, but you need something to slow down the system, to keep it in place, to allow it to continue pelting and pummeling and using up all of that precipitable water over one concentrated area. And we had that in the form of a blocking pattern. Now, these storms mentioned earlier, they formed along a cold front, as storms typically do. Winds at this time of the week were blowing from south-north. They were southerly winds blowing from the south to the north. So the storm's low-pressure system was pushed up into the New England area from these southerly winds, but then suddenly couldn't go any further. And the reason being is there just so happens to be a very large high-pressure system near Greenland, pretty much acting as an atmospheric roadblock, stopping this low-pressure system from advancing any further. So you have this low-pressure system. It's still circulating, by the way, as low-pressure systems do. It's in the New England area over Vermont. It can't really move anymore. It's moving incredibly slowly because this high-pressure system is essentially overpowering it and stopping it from advancing any further. But it's still circulating. The low pressure and all these storms are still circulating, meaning they're continuing to use up that precipitable water. They're continuing to develop more and more storms. The storms develop, they exhaust themselves, it circles back around and develops more and more. This is called training. This is known as training, which is pretty much repeated areas of rain over the same region in a short time frame. It gets its name from, think of rail car after rail car after rail car. When you see a train cross and it just keeps coming and coming and coming, there's no end in sight. Kind of apply that to the atmosphere. In this situation, you see where the name comes from. Training is just repeated rain over the same area in a short time frame. There's no end in sight. This blocking pattern in the atmosphere, this low pressure system of all the storms, stopped over this region thanks to a high pressure system further up in the atmospheric highway, if you will, preventing it from moving anymore. And that prevention is going to lead to this training. It leads the low pressure system continues to circulate, continues to develop more storms, using up all that precipitable water in the atmosphere, leading to incredible rainfall amounts, anywhere from 6 to 9 inches, depending on the locality. That's incredible. Over a 2-day span, that is a lot of rain. And with Vermont being the way that Vermont is shaped, led to a lot of flooding, a lot of conditions led to even additional flooding, pretty much leading to the worst flooding event in Vermont since 1927. It was a very catastrophic week last week for the state of Vermont. Thanks for listening to this week's episode. If you enjoyed the content or commentary, please consider leaving a rating so others can also find this podcast. Enjoy your week and keep your eyes on the skies.